I'm talking about distributed remote monitoring. Daniel, I work for a company called EnvisionApp, and I do a lot of Go. But one of the things that I'm really interested in besides just Go is monitoring, specifically remote monitoring. So I'll assume that most people are kind of familiar with monitoring, to some degree at least, so we won't go into the basics. But one thing to point out here that we're talking about remote monitoring. So not agent-based monitoring, we're talking about remote. So knock on the door, see if everybody's alive type of thing, versus looking at metrics, that sort of a thing. So first things first, what is 9 volt? 9 volt is a distributed, modern, hopefully remote monitoring system written in Go. Obviously, because it's written in Go, there's a bunch of freebies that we get, such as there's a tiny footprint, ease of deployment. Yeah, it's just it's easy going, right? So on top of that, it's using an etcd backend for everything. Because it's using an etcd backend, we're able to do everything event-driven. So this means that you never tell 9 volt to, hey, you need to reload your config or do something else extra. All you have to do is just basically push a config to etcd or talk to a 9 volt API to do something, and it'll automatically pick up the changes and do whatever is necessary. So either stop an existing monitoring check, or stop or start a new one, or distribute it somewhere else. You can basically think of 9 volt as a modern alternative to Nagios. There's a bunch of other monitoring systems out there, obviously. There's Prometheus and Sensu and all kinds of other stuff, and they're all pretty great. But the focus for us here is really just to focus on, well, remote monitoring only, right, not agent-based. So, and what's kind of cool is that it's used in production as well. We're using an EnvisionApp to monitor a lot of our single tenants and stuff, and it's used at a few data centers in Florida as well, which is kind of neat for basically monitoring all the dedicated and colocation servers. So kind of cool. So why 9 volt and why another monitoring system in the first place? So one of the big things is that it's incredibly easy to achieve like really, really large scale. I was actually going to do a demo of it, but then I realized that it would take a while and it'd be kind of complex, and I was drinking a lot yesterday. And all of the 3 days as well, actually. So if there was any chance of doing a demo, that's not happening now. So forget the demo, but it is extremely easy to scale. That was like one of the core tenets, really, of 9 volt. The idea was that you basically could just start up a 9 volt instance pointed at the same etcd cluster, and it's just going to automatically figure out leader election is going to just join a cluster. That's kind of a cool deal because, well, for a lot of other stuff, it takes a little bit of jiggering and doing things to actually get some sort of clustering functionality, or like HA or whatever else. So that was a big thing. There's an extremely simple interface for writing new checks and alerter types. I think the actual implementation is something like, for a really basic check, it would be about 25 lines of code actually. Right now, it already comes with HTTP, TCP, DNS exec. But to add something else, let's say if you needed, I don't know, your service is running like, it's using gRPC, for instance. You could easily write a check, probably in like half an hour, that's actually going to talk gRPC to your service and perform checks and so on. Same with the actual alerter interface. It's the same exact thing. I think I wrote the Slack thing in like less than an hour, maybe. It's really incredibly easy. So there's automatic check redistribution and distribution. So meaning if a member joins the cluster, the leader is automatically going to see, like, whoop, there's a new member. Now let me take all the checks that I have and let's redistribute them across all the members that are still there, or that are there now. Similarly, if a leader dies, then a new leader will get elected, and the new leader will redistribute all the checks across all the members again, which is really neat. So check additions, check removals, member joins and disappears, all that stuff. And another well, there's a lot of functionality really in 9 volt overall. It's been in progress of development for I think it's been a year now or so. But one of the really neat things, in my opinion, is the fact that you can set basically check affinity. It's a really weird esoteric problem, but it happens. Where imagine you have a bunch of single tenants all over the place, and they're all in different VPCs. How do you, and they're all not interconnected, right? Like, how do you check every single one of them? So this check affinity thing helps you with that. That you're able to actually say that, like, if you have, let's say, 20 9 volt instances in the US, 20 of them in, I don't know, EU, and let's pick a Madagascar, 20 Madagascar nodes or whatever. Why not? That's, I'm sure modern Modern Go stuff is big in Madagascar. So yeah, you could basically say, like, I want most of the checks, I don't care where they run from. But for these 20 services over here, they absolutely must be running only from Madagascar, while retaining this actual same cluster that you have, which is kind of cool. So that's a possibility. So another monitoring system, and why? But you guys noticed yesterday that there was a talk about a key value store from Couchbase, and it's another key value store. And I feel like it's kind of in the same space, where it's like there's very specialized things for a specific topic, right? MOS is there for a reason, and likewise 9-volt was there for a reason as well. Mostly because, well, the primary tenets really were to basically keep it simple, make it really, really easy to cluster, and establish clusters in the first place. Also, we're not really focusing on agent-based monitoring, right, where you're actually collecting metrics and doing like metric-based monitoring and alerting, like such as, let's say, Prometheus, or I think to some degree Sensu as well. We're purely just like about the "Are you alive?" scenario, right? So yeah, because of the fact that we're going on simplicity, we're really going for easy clustering, super easy deployment story, because it's a single binary. You just basically push it, whether you're running in Docker or wherever. You essentially just get this binary on there, on some box or in Docker, execute it, and then you're done. It's already running, and it's actually you're establishing a cluster at that point. And there's hopefully no management at all involved. In reality, like, you're putting up these 9-volt instances, and if they die, they die. That's okay, like, because the rest of the cluster is going to figure it out and is going to redistribute checks whenever it feels like, whenever it sees that something actually happened to the cluster. So you really essentially don't actually have to ever talk to these individual 9-volt instances. You just talk to etcd instead. So, and most importantly, it's the ease of integration. Every single place that I've ever worked at, everybody has custom pipelines, meaning whether it's Travis or Jenkins or Circle or CodeShip, doesn't matter. Everybody does something well, not semi, in most cases fairly complex. And everybody wants to do the golden idea really is to have monitoring that's set up on the fly, like meaning a service gets deployed, you set up monitoring. A service basically disappears, you want monitoring to be pulled out. I've seen every possible implementation out there with chef runs and puppet runs and all kinds of weird queue-based systems where people are pushing a message and saying like, oh, you need to redo monitoring. Well, the idea here was that, well, you just talk to etcd and you say like, hey, by the way, here's a post, just monitor this thing for now, and then here's another post or a delete, and stop monitoring this, and it just all happens for you automatically, and that's kind of neat. I was going to have a bunch of slides, which actually were showing this crazy setup and whatnot in this problematic scenario, but I deleted all of them because, like I said, I was drinking a lot, and there's no possible way that I would actually be able to go through it, because I've got 1 minute and 44 seconds left. So this is this convoluted, weird setup where basically there's a bunch of VPCs, a bunch of single tenants, and as you can see, there's the X's in there, which basically means that none of them can talk to each other. And how do you monitor something like that? Well, the idea is that, as you see, those errors are actually going outbound, and that's much easier to achieve than going inbound into checking each one of those services that is running each one in one of those stacks. So in this particular example, we're going out to etcd, and we have one centralized place to actually, check everything. So it's kind of neat. I think it is. All right, that is it. I am under 10 minutes, guys. I did this. All right, thank you.